Hi.
Hello. Welcome to this presentation. I'm Martin from Bondtech.
I'm Olof.
Amazing to see so many people here. What I'm going to talk about now is a little bit of the journey that Bondtech has made from the start, more or less, and where we ended up now. A bit behind my background, I'm a mechanical engineer, working with everything from injection molding, mold design, laser cutting, sheet metal, robotics, a lot of different things. But CAD has been one of the big driver, 3D CAD in my life, more or less to say. When developing other products, we of course get in touch with the 3D printing, and it was amazing to see what I can go from CAD directly to a physical model. So that was really sparking my interest in why I started with this. So of course I built a printer and had a lot of issues. So this is really one of the first dual drives that I have designed back in 2013, 2012. I really had a lot of issues trying to find a stable feeding solution, because that was creating a lot of issues for me. So I designed these dual drives, and it really worked as magic. It really get away that problem. So therefore I understood, okay, I had the problem. It seems like many other people had the same problem. So I decided, okay, this seems to work really good and it solves an issue. So I tried to build a company around that. So that was the start back in 2013. Since then, this was some of the CAD designs, really early CAD designs, and printed prototypes. The one that is on the further right, that is actually alive still. You can still purchase it. It is a V2, we call it. People still buy it. It's a really good, strong feeder. So this was my prototype printer that I built, that I had a lot of feeding issues on. So that was really the start of Bondtech, why I needed to solve these feeding issues. So from this, I was at Midwest RepRap in 2015. That was the first time visiting US here. It was quite small then, but it was really quite a big interest for the products. So here is the first production site. It's my own garage in the house, and my two oldest boys are also active in this. So this was really, you can see December, January 2015. So that was really the start. So, but we were producing in house. Also, my wife is there in February, packing orders. So this was the first outside location outside my house, where we started to build the production. Here was an exhibition in Sweden that's my other son on the photo. So this is when we got the first CNC machine.
So that's like the first BMG prototype?
Yeah, FDM printed BMG. So here was the first factory, more or less to say. At this time, we also delivered the first orders to Prusa, where they started to use our dry gears in their multi-material solution. So in the year after, we moved into another facility that was larger, more space for us. So it was really empty to start with. But a lot of construction work going on there, building offices and everything. And the production grew as well. Some shows in UK, I think it was. Here is the first CNC lathe installed in 2018. Now we were starting to produce nozzles as well, and then it was a second machine. And now we were also starting the build of the new factory. It was in September 2023. It was built during the winter.
Yeah, so that was a bit larger than the old factory.
Yeah, it was 4 times as large.
Yeah.
Yes.
And now we're looking at doubling that size.
Maybe. Yeah, and here was the big move when we moved from the old facility to the new place. Moving heavy equipment. So this is the new facade of the new factory. And for INDX, I guess there are some questions about INDX as well. So we will do a Q&A.
We're going to use the rest of our time here to do Ask Me Anything about INDX, Bondtech, anything like that. So if you got a question, just raise your hand. Yeah, that guy over there. Shut up. We're going to open up for pre-order soon, hopefully during May. We're going to announce the dates within a week, hopefully. Yeah?
Did it wind up being a larger project than you thought it would be when you announced it?
Yeah, for sure. I mean, not only because we wanted to make it better and iterate on the design, but also because we got involved with Prusa, and they also wanted that. So yeah, a bit larger than we expected, for sure.
Can you maybe give us some basics? What are the advantages of this and what is it actually? It sounds interesting. Exactly.
Yeah. Okay. So I guess for anyone who doesn't know what INDX is, it's a tool changer, not a tool head changer, but we only change the bare minimum that we have to change. That means the filament path, heat sink, heat break, and nozzle. And the nozzle, we heat that inductively. So it's a ferromagnetic steel in the nozzle. This allows for very fast heat up times, very fast cool down times, which means that the polymer doesn't have a lot of time to degrade in the nozzle while hot when we park it. We also have something that we call dynamic dual drive, which basically means that we have an attack angle of the drive gear from the pivot point of the fixing of it, which means that when it runs into more resistance, the gears dig in harder against the filament. So we can go from your rigid nylon filament, carbon fiber filled, and just swap over to TPU without changing any tension settings or anything like that.
The drive stays on the head. You just change the
So everything. Yeah, everything besides the filament path, heatsink, heat break, and hot end, nozzle stays on the tool head. So your stepper motor, your heating coil, your electronics.
Yeah, the tool is completely passive.
How many colors can you support?
I think there is a limitation today in Prusa Slicer that is 32. Yeah, but that is software, so it's easily scalable. What you need is the physical space for it.
Yeah, to be able to fit the number of tools.
Yeah.
How does INDX compare to Bamboo Labs AMS?
So INDX in comparison to Bamboo Labs AMS or other similar systems for that matter, we have a lot faster changeovers, since we don't have to purge anything or retract the filament or anything like that. I think those types of systems can maybe do 30-40 seconds at best, while we are at 17 seconds at worst. But we have done changes including priming the nozzle in 8-9 seconds. Yeah, over there.
You said you're going to be working with Prusa. How are they? What are they going to be doing with your tech?
Yeah, so we're working with Prusa on this as a partner, and we have a special edition of the toolhead for their system. And what's different about that is basically the toolhead board and driving electronics. So it's going to be the same drive gear, same toolhead when it comes to not electronics.
Yeah, same tools.
Yeah. Exact same tools and everything. Yeah, back there. Yeah.
What kind of nozzle materials and diameters are we looking at?
So nozzle materials, we have to do ferromagnetic steel because the induction needs that to work. We are looking at like partnering with different manufacturers for different like tips and maybe surface treatments and stuff like that. We do have hardened nozzles as a standard right now, and you're going to be able to print your carbon filaments just fine with those.
And software, I mean, so this is gonna be specifically tied to a printer. Okay, you have add-ons to any printer.
You can add this to a lot of different printers. We provide reference geometry on our GitHub right now. It's primarily going to be for Clipper Calico-based systems or RepRap firmware right now. Yeah, back there.
What's the flow rate going to be?
Flow rate is, I mean, it's not really a blanket number you can get. It's going to be different depending on exactly what filament you're using, what temperature, etc. But if we're going to give a blanket number, it would be 40 millimeters cubed. That being said, we have done up to 75 millimeters cubed with a 0.4 nozzle. Yeah.
Are there any plans to offer tailored solutions for the common, like a boron or something like that? Them look at?
Yeah, so we know a lot of people want tailored solutions for the printers that they have, obviously. Since we're looking at so many different printers that it can go on, that people want it on, we're doing something different now. In the past, we have always sold upgrade kits and maintained them ourselves. Now we're putting it in the hands of the printer designers instead, or the community for that matter. So we have like Steve from Voron Design, who does the printer design right now. He's doing that integration for Trident, at least maybe 2.4 as well. We have the RatRig team working with the integration design on their end. Yeah. Yeah.
With the dynamic filament tension, is that a mechanical or like software-based?
Yeah, so the dynamic dual drive, it's all mechanical. It's got to do with the angle of attack of the pivot point for the drive gear assembly, basically. Yeah, back there.
Are there any other companies you want to work with besides Prusa?
We have chosen to only work with Prusa for now. And I mean, that's in regards to a customized solution for their machine. Anyone is, of course, welcome to reach out to us for the developer kit version to integrate that as it is. Yep.
Are there plans to open up the INDX system to the community in the future?
We're not going to open it up as in open source, but we are going to open up as much as we can where it's relevant, because it's not an easy system to assemble or do modifications to or anything like that. So we'd prefer to keep it like, for now we have the front covers, for instance, that's open reference geometry, so you can do like your own customized look of it all. Yeah. Yeah.
When you switch between nozzles, do you have to calibrate like, the alignment between them, or is that consistent enough that's not needed?
Yeah, so we're not sure yet. That's the short answer. You're probably gonna have to be able to calibrate in XYZ, but we have a load cell in the tool head, and we're working on very like simple macros that makes it really easy to do that calibration. That being said, we're also working on a machine to straighten nozzles to get that offset variation as small as possible. Yeah.
You mentioned a load cell. Will that be accessible for use with like UPA sensing?
We're not sure about that yet, if it's granular enough for it, for automatic pressure advanced calibration. But if we get it running smoothly enough for that, then for sure. I mean, all the data is there. We're using a load cell integration in Calico done by a guy named Gareth. And so it's very exposed. Yeah? Anyone else?
How much does it cost?
Yes. we haven't announced final pricing yet, but I think that the prices for the Founders Edition should be. Maybe we're not going to be able to keep that price, but it should be very close.
Yeah.
So about 350,
For the tool
350 up to 400 maybe for the tool
LED.
head,
Yeah.
and 35 to 40 for the tool.
Yeah.
Yeah.
The Core 1 Founder Edition, you mentioned it's got a different board, right? If you were going to move it to another system, is that going to be something in the future that's possible, or is it just a whole new system?
So using the Prusa Core 1 tool head board on a different system, depending on your aptitude for developing like Modbus integration in Clipper, you're gonna be able to do that, yeah. Yeah, anyone else?
What was the biggest unexpected challenge that you guys have faced with this?
The biggest, I don't know. There have been so many.
I mean, the whole like pickup sequence, like opening the extruder and how to trigger that opening has a lot of development has gone into that. Initially, we started developing this as kind of a quick swap manual, quick nozzle change system, but then we pretty soon figured out that maybe we should make it an automatic tool changer.
Exactly. Yeah.
Yeah. So the limitations primarily will be chamber temperature and nozzle temperature. Right now we're at 60 degrees Celsius for the chamber and 300 for the nozzle. Getting higher isn't trivial because we're using infrared to measure the temperature of the nozzle, and that sensor itself can't get too hot. So managing those thermals are pretty much what's setting the limit. Yeah. Prusa are going to be selling it, very soon. So the upgrade kits for the Prusa machines are going to be sold by Prusa.
Here we can see some production photos. So this is the nozzle tips that are being machined, ready for cleaning.
Yeah.
Will there need to be a different tool then for USB and CAN bus?
So right now we have CAN FD, which is only supported by RepRap firmware right now. We're working on because we don't really need to change hardware to support the CAN bus version that Clipper uses. We do need to find room for that in the bootloader. We're working on that, but right now there's a split, like USB for Clipper Calico and CAN bus for RepRap firmware. Yep.
Yeah, some production photos. Here is our CNC department. We have 6 Swiss lathes now running as much as possible, producing parts. We also have some CNCs, vertical CNCs that were used to machine some parts of the product. Try to do as much as possible in-house. There will be injection molded components in this as well. We will not inject those in-house. It will be done at the supplier. So I think everything is coming together nicely, but for sure has been a challenge.
Yeah, I don't know how many parts are in the tool head.
I think we are over 100 parts, individual components in the tool head.
Yeah. So it's not simple.
No.
Okay, do we have any more questions? Where are we at in time? We're only gone for 20 minutes.
Okay, yeah.
Dimensions of the tool head.
The physical dimensions are, I think it's 52 millimeters wide,
Yeah, I think so.
and the height is about that.
52 by 52 by 52?
No,
no.
it's higher. Yeah.
Yeah.
We have one in our table here at the show, so you can please come by and grab it and feel it. And we also have the tools, so you can feel it.
And it's also on our GitHub, so you can
Yeah.
measure it out there. Yeah.
How does the hot end volume change compared to others? Is it larger or smaller?
So the volume of the nozzle, internally it's pretty much the same, right? But we have the CHT, which allows for a bit more surface contact. As for the length of the melt zone, that's
Fairly standard.
like 28 millimeters. It's longer than your V6, but yeah.
Do you know the volume in microliters?
No, I don't. Sorry. You had a question?
Is there anything you're excited that you're hoping the community does with this?
Yeah, I mean, just seeing how they customize things, smart macros they can come up with, and of course the prints. It's going to be exciting to see a bunch of new like multi-material, multicolor models hit them.
Material combinations and integrating flexible and stiff material in the same print in a smart ways that opens up for a lot of new possibilities, I think, combining materials.
For sure.
For an inductively heated kit like this, or trying to develop a kit, what are some of the power requirements?
So the power requirement is about 50 to 60 watts. So you're most likely not going to have to change your power supply unit as long as it's 24 volts. I mean, you could run it on 12 volts, but you get like a quarter of the heating power. So probably want to run it at 24. Yeah, okay. Do we have any more questions or? Yeah.
You mentioned that compared to traditional tool changers, that there may be some changer temperature limitations and things like that. What do you see as the advantages of your system compared to the traditional tool changers? I see certainly a number of tools in a certain space, but can you expand on some of that?
I would say that the main advantage of this system is that it scales very good, since we also have we can place the tools at about 34 millimeters center to center distance, so you can fit a lot of tools. Like for instance on the Core 1, where you have about 255 millimeters of X travel, you can fit 8 tools. That's gonna of course be impacted on depending on what part cooling solution you choose, because the part cooling adds a bit of width to the tool head, and so you can't fit as many tools. But like worst case, it's about 40 millimeters center to center distance, so it's not too bad. Yeah. Yeah.
What's the most amount of nozzles you've been able to?
We've only used 10 at most, I think, 9 or 10. But I'd love to see it on like an Orange Storm Giga. Yeah.
Yeah, so with the inductive heating, the tool heads heat up and cool down quickly. Have you done the experimentation with heating and cooling the tool head so it print rather?
Yeah, so that's a good question. We haven't really done like temperature modulation during extrusion, but we are aware of it being like maybe a big pro of this system. So we're gonna experiment with nozzles with shorter melt zones, so we can modulate like foaming TPU PLA a lot faster. Yeah. Yep.
You mentioned which cooling solution you choose. What options do you have?
So right now the 2-part cooling solutions we offer are basically shrouds that we mount on the sides of the tool head. Either it's 40-10 dual fans, blower fans, or CPAP ducts, so you can force a lot of air through it. On some printers you may also be able to use a part cooling solution similar to Prusa, where you go from the back of the X-beam. That lets you keep the center-to-center distance of the tools very minimal.
Yeah, and we share the geometry of the outside so people can design their own system.
Yeah, and I mean you could integrate your part cooling into the front covers to minimize the amount of space it takes. Yeah?
So what about some of the buildings that have metal, the infill, how they kind of glossy, but some that has iron, or how would that work?
I don't think it would be any different, because the induction it only goes like 0.5 millimeter deep in the metal, so they wouldn't be affected by the induction, I think. We haven't tested it though, but it shouldn't be affected by it. Yeah.
So one of the limitations with current slicers is they don't handle the mixed sizes very well. Do you know if any work's being
we have Soft Fever on the beta testing team, and he's the guy who's developing Orca Slicer. So we're looking into it. Any more questions? Anything? Yeah.
I know you still have to purge a little bit to keep things well. Can you compare how much filament is used in the purging versus some other systems? Is it plastic, aluminum?
Yeah, I think we have a photo somewhere of where we used a very popular mainstream printer compared to the Index, and I mean it's night and day. It's I don't have any numbers for you, but we prime anywhere from 5 to 15 millimeters of filament, so it's very little.
For that specific print, I think I remember the right figures, but I think the part weight was 33 grams. It's a 2-color print. It took 12 and a half hours on that machine, and it took and the waste of with that print, I think it was 140 grams. When we tried it with Index, the waste was 7 grams, and the time was 2 hours and 45 minutes. It's a huge difference both in time but also in waste.
Yeah.
And I have the photo. We can share it. So.
Yeah. Yeah.
Is there any specific material that's been the hardest to get with the system?
No. I mean, we're very comfortable with extrusion and different filaments, so I wouldn't say so. Of course, TPU is going to be tricky. You can't really do like combined TPU PLA in a wipe tower, so you have to do some kind of off-bed priming for that. But if you have a look on the Prusa Core 1 system, they have solved that beautifully, I think. Yeah. And that's pretty much everything from us, I guess.
I think so, yeah.
Unless someone has a question, yeah?
Yeah, it's not a good question. I'm pretty new to 3D printing, and in my short time, I've seen single nozzle, single color to AMS light to now, all kinds of new technology, even with the laser resin type deal. I'm one of those guys that bought the laser disc instead of DVD. So I'm going to go that route.
Nice.
So I'm always cautious before I go out and buy the next machine, right? I'm wondering in 5 years, where do you see things going?
That's impossible to answer. Yeah. So much can happen in just 1 year in FDM 3D printing. So I guess maybe like non-planar stuff, hopefully it's going to be a bit more accessible.
I think that is one thing that we will see in the future, non-planar, making more effective prints.
Yeah, and just like have you guys seen the, what's it called? The one that mixes the colors at different layers? Full spectrum, yeah. I mean, that came out of the blue pretty much, so who knows what's next. Yeah.
Since induction heating isn't commonly used, I think there's only like one other nozzle that uses that. What were some of the difficulties in, especially getting that shape that you guys have?
It was super simple. We had a really smart guy presenting us with the idea, and that was pretty much it. yeah, for sure.
Yeah, but again, one of the challenges there was getting the electronics really compact to be able to fit the induction drive circuit. Yeah. So that was quite complex. But we, as Olof said, we are really smart guys in the teams that have solved that. So
yeah. I mean, hopefully we'll have people buying this for a long time. If the day comes when it's not interesting for us to produce it anymore, maybe we can open it up and someone else can produce it. So we don't want to leave anyone hanging, of course. Yeah.
I know this is taking a lot of your bandwidth right now. When this is put to bed, what do you think you'd like to take on next?
I mean, the next one is probably going to be the industrial version, where you can do a bit higher nozzle temp and a lot higher chamber temperatures. We're also looking at maybe doing a standalone dynamic dual drive extruder, to surpass the LGX, pretty much. Question down there? Yeah?
Is there any options for say, things other than FDM, so tools that are, for example, a cutter?
Yeah, I think a cutter is maybe, because we can't really push that hard with the tool. But definitely we're gonna offer like the coupling. For now we use a Maxwell coupling, so we're gonna offer like blank heat sinks, so you can customize do your own tools basically if you want to do a pen or a laser or
ironing
or a oxyacetylene torch or something like that. Yeah. Yeah.
Have you tried peak printing?
We can't really get up to those nozzle we can get up to red hot pretty much, but it's not. We can't really read those temperatures, so no, we haven't. Yeah. Anyone? Okay.
Specific to the Prusa implementations, the Core 1L and the Core 1 Plus have that chamber vent, the automated opening and closing the vent at the top. Are you able to preserve that functionality?
No, we unfortunately can't add. Maybe someone can figure it out, but we haven't really figured it out because the vent is so much higher now. So you're gonna need a big rod up there to actuate that. But there's some good like community designs out there to utilize like a servo. So I would probably look at one of those solutions. Yeah.
So you said you sort of implied that the limitation on your nozzle temperature is the infrared measurement system. That's why you can't go higher than the 300.
So we have pretty much two limits. The first limit is the heating of the temperature of the IR sensor itself, and we're hitting that at 60 degrees chamber, about 300 on nozzle. The next limit is going to be about 350 because that's where it stops reading temperature reliably. So, but we're hoping to at least get up to 350 for the industrial version for your PPS, PPA type filaments. Okay.
Okay.
Then we say thank you for this.
Yes, thank you.
We're in a booth down by the other hall by Prusa. So if you have any further questions, feel free to come on over. We have some printers there doing tool changing as well.
And also some loose tool heads and tools that you can
check out and feel.
Yeah.
Yeah. Thank you.
Thank you.